So, in this video, we are going to take up one more problem on projections of lamina. How to solve this problem and how to analyze by using the manual sketch. How to write a manual sketch. I will going to explain in detail. The problem reads as a triangular plane figure of sides 25 mm is resting on HP with one of its corners, such that the surface of the lamina makes an angle of 60 degree with HP. If the opposite to the corner on which the lamina rests makes an angle of 30 degree with VP, draw the top and front views in this position. So this is the problem. So for that, how to start the problem? So here, since you are given the surface inclination with respect to HP, so first what I need to do, I need to take the surface parallel to HP. So that means the surface inclination with respect to HP, you make it 0 degree. That is what we have done in this particular case. And then whether it is resting on the edge or the corner, always the initial position has to start from the top. Because once the surface inclination is parallel to HP, so that means I can keep the lamina on HP because it is resting on one of its corners on HP. So, since the lamina is in HP, obviously the line is parallel to HP. Since it is parallel to HP, then you are going to get the true length in HP. Where is the HP? HP is in the top view. Therefore, I need to start the problem from the top view. Whether the lamina is resting on the edge or the corner, the initial position has to be such that the edge, one of the edges is perpendicular to VP only. So how do I know that once the surface is parallel to HP, what happens to the surface with respect to VP? With reference to the VP, it will be perpendicular. Therefore, when you look from the front view, you can see that you are getting a line in vertical plane, because once you look from the front view, the image will going to fall on VP. How do I know that it is parallel to HP? You can see A dash B dash is on HP, B dash C dash is also on HP, and C dash A dash is also on HP. Since all the points are resting on HP, obviously that is parallel to HP. So we can, once it is parallel to HP, we can see the true length in HP. So where is HP? HP is in the in the top view, and I can see the image of the triangular plate figure will be seen in the horizontal plane. Therefore, when you look from the top view, you can see that you have a side, a triangular plane figure having the side 25 mm, BC 25 mm, and CA. So what are the positions of AB, BC and CA with respect to both HP and VP? If you see, the line AB is inclined to VP. Since the line is inclined to VP, so in vertical plane, you will going to get that line in apparent length. Similarly, BC is also inclined to VP. Therefore, B dash C dash is again in apparent length. Since A dash C dash is parallel to HP, so you are getting the true length here. So the position of the line A dash C dash or AC is perpendicular to VP and parallel to HP. Therefore, since it is parallel to HP, you will get this line will be in true length. But since all the sides are parallel to HP, therefore in HP you are getting all the sides of equal length of 25 mm. So how do I know that this is the edge? When you look from the top view, you can see AC is the line which has got having an edge, and B is the one wherein you have only one point, and that will going to be the corner point. So this is how we can be able to analyze it in the first position. Now you can see how to draw this. First I am going to draw an XY line and you mark VP and HP. So I will start from the top view. So I will going to draw a triangle of 25 mm and you mark this point as A, B and C. Then you project all these, draw a vertical projector from all these points to the XY, because he says one of the corners is resting on HP. Therefore, when you look from the front view, A is near to the observer, so it becomes visible. B is near to the observer, so it becomes visible B dash, and C is away from the observer and it is coinciding with A, therefore C dash will be invisible. Whatever we have written here is the same view of this, and whatever we have written here is the same view of this. So this is how we will be able to write the orthographic projection. Now, then what he says, it is resting on one of its corners. Here it is resting on one of the sides. If you want, if this is the side and this is the corner, then what I need to do? So I need to rotate the first position top view. I need to rotate the first position top view such that it becomes the surface, and this shaded portion is the one which is being rotated such that you can see the entire surface is inclined at 60 degrees to HP. As you are rotating this object from the 0 degree to 60 degree, so what happens to the image in the front view? The image is also being rotated. So as we rotate this surface to an angle of 60 degrees, till what you will going to be rotated? Till this surface becomes 60 degrees to HP. So when you look from the front view, this surface still perpendicular to VP, therefore you are getting a line here. And you can see it is resting on one of the corners, that is B. Then when you look from the front view, you will going to get, when you project this point, you will going to get A dash C dash. A is near to the observer, so it is visible. C is away from the observer, so it becomes invisible. And then B dash is resting on HP. So join between these two, you are going to get the surface inclination. Since you have changed the position in the front view, obviously when you look from the top view, here B, you are going to get B directly because B is on the horizontal plane. And when you project this point till here, you are going to get this is A and this is C. Then join A to B, B to C and C to A. Now you can see that here AC is parallel to HP. Therefore, you are getting the true length here. Since AB is inclined to AB is inclined to HP, therefore, in HP, you are getting the apparent length. Similarly, BC is also inclined to HP, therefore, you are getting the apparent length here. That you can see evident here. A dash B dash is inclined to HP, therefore, AB is in apparent length. B dash C dash is also inclined to VP, inclined to HP, therefore BC is also in apparent length. A dash C dash is parallel to HP, therefore you are getting the true length. So what is the length of the true length? The length of the true length is 25. So here also AC is 25, here also AC is 25. But AB and BC is not, here it is 25, but here it will not be 25, it will be less than that. So this is, what is the position of this? With respect to both HP and BP, the surface is inclined to HP 60 degrees and still that surface, still it is perpendicular to BP, therefore you are getting a line in the front view. Now, when you try to do this, how I can do this? So here I want to rotate this such that the surface inclination with respect to HP will be 60 degrees. How can I rotate this directly from here? No. So as we rotate this, what happens? This surface is also getting rotated. As you rotate this by an angle of 60 degree, then what happens to the image? Image is also get rotated. Therefore, you take from here any convenient position, as he says that it is resting on one of its corners. Since the corner is a single point, so this is the corner. So I take any convenient distance and you mark that point as B dash. Then by using the protractor, you measure an angle of 60 degree with respect to XY line and then draw an inclined line. As we are rotating this, surface by keeping the corner on the HP, so what happens to the image? Image in the front view is also getting rotated. So therefore, you have to copy this line here such that at an angle of 60 degrees. Therefore, from B dash, you measure an angle of 60 degree and draw an inclined line with respect to the horizontal. Then by using the compass, you measure the distance from B dash to A dash. With B dash as center, cut an arc on this 60-degree line and you mark that point as C dash and A dash. A dash is visible, C dash becomes invisible. Then join between B dash and A dash with a dark line. Then now I need to write, as the position is changed in the front view, obviously for that I need to write the top view. So whatever we have in this view is the same of this. Then I need to write the top view. I need to get this. How do I am getting this? I am drawing a line from here and I am taking the projection from here. Similarly here also, draw a vertical projector from A dash and C dash and draw a horizontal projector from A and also from C. Both these two lines will going to intersect at these 2 points and you mark this point as A and you mark this point as C. Similarly, draw a vertical projector from B dash and draw a horizontal projector from B. Both these two lines will going to intersect at this point. So you mark that point as B. So join A to B, A to B, B to C and C to A with a dark line. So this will not be in true shape because as A dash B dash is inclined to HP, so obviously this line will not be in true length. As B dash C dash is inclined to HP, BC will not be in true length, but whereas A dash C dash is parallel to HP, therefore you are getting the true length here. So since two of the sides are not parallel, therefore you are getting the apparent length. So obviously this will not be in the same shape as this. This is the true shape because all the 3 lines are in true length, but here only one line is in true length. The other 2 lines will going to be in apparent length. That means instead of having AB equals 25, it will be less than 25. Similarly, BC also will not be having 25, it is less than 25. So this is how you will be able to write the second position front view and also the second position top view. Then what he says, the side opposite to the side on which it rests, which is the side opposite to the corner. Here on which it rests, this is the corner, opposite to that is this side. That means what? If B dash is the corner, opposite to that side is A dash C dash. How do I know that? You can see here, the corner is here, whereas opposite to this corner is AC. So this corner is here. How do I know that the corner is resting on HP? You can see that the B dash is on XY line in the front view. So that means since it is on XY line, so it is resting on HP. So the image will going to be seen in vertical plane. Whatever you get the image in the vertical plane is the front view. Therefore, it is B dash is the corner, opposite to this corner is the side. So what happens to this side now? This side is still parallel to HP. Therefore, you are getting the true length in HP. Now, he says the side opposite to the corner is making an angle of 30 degrees. So what I am doing is, I am rotating this surface such that AC now is still perpendicular to VP. I want to make it inclined to VP at 30 degrees. So I am rotating that in space like this. So once you rotate like this, what happens? This AC is inclined to VP. Since this is parallel to HP, therefore, you are getting the true length in HP, and this is also still in true length, and the inclination what is given is the true inclination. Therefore, from the projections of lines on true inclination line, we will going to get the true length. As AC still is in true length, the inclination given is also a true inclination. Therefore, you rewrite the same sketch by rotating at an angle of 30 degrees to VP. That is what we have done here. So once you do that, then when looking from the top view, B is already on HP, and you project this point from C to this and also from A to this. So then join B to A, B to C and C to A. So this will going to be the third position top view. That means I am rewriting the same sketch by rotating at an angle of 30 degrees to VP, such that this side AC is the side which is inclined to VP at 30 degrees. Now I need to write the front view. When you want to write the front view, so B is projected onto the XY line, that is B dash, and A is projected onto the vertical plane, and from A dash you draw a horizontal line. Both these two lines will going to intersect at this point, which is A dash, and also draw a vertical projector or draw a projector from C to the vertical plane, and both these two lines will going to intersect at this point. It is C dash and B dash is already marked. Then join A dash to B dash, B dash to C dash, and C dash to A dash. So this is how you will be able to write the front view for the third position. Whatever you got, so this is how you will be able to write the third position in 3 dimension. Now, once you rotate this horizontal plane downwards, so all the images will going to be taken into the horizontal plane. See how it will going to consider. So what I am doing now, so here the side opposite the corner, the edge opposite the corner on which the laminar rests is making an angle of 30 degree with respect to VP. So since he has given the inclination as the true inclination, and first that is side opposite the corner on which the laminar rests. This is the side opposite is this corner which is resting on HP is now perpendicular to VP. Since it is parallel to HP and perpendicular to VP, you are getting the true length. So from the projections of lines, we know that it is on the true inclination line. You have to get the true length. So since this line is in true length and the inclination given is also true inclination, therefore you rewrite the same sketch by rotating at an angle of 30 degrees to VP. So how can I do that? So first you take any point and draw a line inclined at 30 degrees to VP. Then by taking any convenient distance, from the second position top view, you draw a 30 degree line. Then you measure the distance from A to C by using the compass. You on this 30 degree line, you take any convenient point, and from there you cut an arc on this to get A and C. Then since it is a triangle, measure from A to B by using the compass. With A center, draw an arc. Similarly, from C, you measure the distance of C to B by using the compass. With C as center, cut an arc on this. So, you are going to get the point B. So, mark these points A, B, and C and join A to B, B to C, and C to A with a dark line. Once you do that, then we need to project it. So, draw a horizontal projector, that is, of course, we are extending from B dash, and draw a vertical projector from B to the XY line, and you mark that point as B dash, and draw a horizontal projector from A dash and C dash, and draw a vertical projector from A and also from C. Both these two lines will be intersecting at these 2 points, and you mark that point as A dash, and you mark this point as C dash. Join A dash to B dash to C dash, and C dash to A dash with a dark line. So this is how I will be able to write the orthographic view of a triangular lamina. How do I know that my problem is right? Even in the final position, you can see that the corner is resting on HP. The corner opposite to the side, which is that the corner opposite to the side is A dash C dash, that is inclined at 30 degrees to VP. You can see that AC is inclined to VP at 30 degrees. The inclination with respect to VP can be seen in the horizontal plane. Therefore, in HP, we are drawing at an angle of 30 degrees. Then, and one of the corner is resting on HP. So you can see that the corner is resting on HP, such that the surface is inclined at 60 degrees to HP. It is also taken, and then we have a triangular plate of 25 mm side. So this is how you will be able to analyze this problem and know that our problem is right. So finally, what we can take away here is in the third position also you can see that the corner is resting on HP and the corner opposite side is parallel to HP. So you are getting the true inclination, that is 30 degree with respect to VP. Thank you.